This is lesson 126 in Saxon's second edition, Algebra 1/2. And this lesson covers two different topics. The first is equations that have x squared. The second is the beginning lesson on the Pythagorean theorem. Alright, let's start with equations that have x squared. Alright, so we know that if we said x squared equals 4, that's really easy to do in your head. It pops into your head real quickly that the square root of 4 is 2. But what you may not have realized is that 2 as well as negative 2 both work for a solution for this. So we would say that x is equal to positive and negative 2 in this situation. Now I've worked it out over here for you like this with the radical sign. That's what this square root sign is called. The square root of 4, I want to show you how you get rid of this square root sign. We know that the square root of 4 is 2, right? So the square root of 4 times the square root of 4 equals 4. Square root of 4 times the square root of 4 equals 4. And this shows you why that is true. The square root of 4 is 2 times the square root of 4, which is also 2, equals 4. So really when you say square root of something times square root of that same thing, you really get rid of that square root sign. So now we've gotten it down to, over here on our equation, just plain old x squared equals whatever the answer to square root of 4 is. Well, like we said, it is both positive 2 and negative 2, so we're going to write it that way. Alright, let's work a couple here. This says solve p squared equals 16. Again, we know that 16 is a perfect square number, and we know that the square root of 16 is 4. But we can also put negative 4 in there and say negative 4 times negative 4 also gives us positive 16. So we're going to write our answer. P equals positive or negative 4. Alright, now but our next example is not quite so easy because 42 is not a perfect square. There's not a perfect square root for that. So what do we do in those situations? Well, pretty much the same thing. We're just going to say p squared equals positive or negative whatever the square root of 42 is. It's going to be a decimal number. And we're not going to figure that out right now. We're just going to say it's going to be positive or negative square root of 42. And that is all you're going to do on those kinds of problems. But do remember to put this positive or negative in front of your answer. Alright, let's move on to Pythagorean theorem. Pythagoras was a Greek mathematician, and he came up with this formula, but the trick is it only works in right triangles. No other kind of triangles can apply this theorem. So, in a right triangle, you have what is called the leg, the other leg, and then the hypotenuse. We have been used to calling it the base times the height because those are the two that form the 90-degree angle. But now we're going to start calling them leg A and leg B. And the hypotenuse is the one that's the longest that connects those two that make the right angle, and it is going to be referred to as C. So really the formula for this is a squared plus b squared equals c squared. Now I'm going to show you why that's true. If we were to draw an actual square coming off of this hypotenuse and a a square coming off of this leg and a square coming off of this leg. When I did the area of each one of these separately, I would find that this holds true. The area of h squared, the hypotenuse, is going to be equal to this one squared plus this one squared. See how it just makes a nice square there off of those sides? So I found this and I thought it might be comical for you guys. It says, "Great Scott, my math teacher was right. I did need to know the Pythagorean theorem. Curses! Now poor Timmy is going to die because of my foolish disrespect for geometry." And yes, Pythagorean theorem is a part of geometry that you're learning. Okay, so in this example, we have the hypotenuse is 5 and the two legs are 4 and x, and we're going to call x A. Okay, so it's going to be A. So it would be like A, and then 4 would be B, and 5 would be C. Alright, so 5 squared, which is the hypotenuse, equals the squares of the two legs. So 4 squared plus A squared. Well, 5 squared is 25. 4 squared is 16. And we don't know what A squared is yet. Alright, so let's move our 16 to the other side. By subtracting, we've gotten rid of that. 25 minus 16 is 9, equals A squared. And I know with our difference of two squares theorem that if I were to put a square root sign over this and over this, it would get rid of this right here. So the square root of 9 is 3, equals A. But remember, this is very important, it's not just positive 3, it is positive 3 or negative 3, equals A. Alright, again, this is like example 126.4 in your book on page 363. It's twisted a little different, and in your book we've got 4 and 5 as the two legs making the right angle, and then instead of being C, we have this as side P. So we can say P squared equals 5 squared plus 4 squared. Alright, P squared equals 5 squared is 25 and 4 squared is 16. 25 plus 16 is 41. Now I know that I don't have an actual square root for 41. It's not a perfect square. So I can say P is equal to plus or minus the square root of 41. Let me go back to that other one. I didn't put the plus or minus, and then it would be wrong if you didn't. Okay, so I think we've done enough practice. I hope so. Let's go ahead and work your practice problems. This is practice problem A, and it says find side M. And you've got a base of 2 and or a leg of 2 and a leg of 3. So we can say 2 squared plus 3 squared equals M squared. Well, 2 squared is 4 and 3 squared is 9. 4 plus 9 is 13, which we know is not a perfect square. Now we use the difference of two squares to say that 13 let me switch this around. M equals plus or minus the square root of 13. See, I took the square root, which did away with this squared, and it made this a square root of. So this would be the answer for this problem. May seem incomplete to you, but it's not. Alright, practice problem B says find side P, and we have the hypotenuse in this situation is 9, and then the two legs, one is 7 and one is P, what we're looking for. So we can start out with 9 squared equals 7 squared plus m squared. Alright, well 9 squared is 81. 4 squared is 49 plus m squared. Well, let's move this 49, shall we? (11 minus 9 is 2, and 7 minus 4 is 3. 32 equals m squared. Now, if we were to put a radical sign over each of these, use the difference of two squares, we get rid of the m squared, and it's going to simply be m, and we would say the positive or negative square root of 32 equals m. Alright, good job. This may be something that takes a little while to get used to. Practice is going to make you much better. So don't worry if you don't completely understand it right now. You will get the hang of it, trust me. Alright, have a good day, and I'll see you back next time for, let's see, are we doing lesson 127? No, we are not. We're going to skip 127 also. So I will see you back next time for lesson 128.